In this first of two-part presentation of adding unlike fractions, I'm going to cover the basic concepts behind how we can add two unlike fractions together, where unlike fractions means that the denominators are different from one another. So I've drawn two unit squares, and each of them is subdivided into a different number of equal-sized parts. So the first unit square has 1/2 of it shaded. The second unit square has 1/3 of it shaded. And again, remember, the numerators of the fractions represent the number of shaded parts. The denominators represent how many equal-sized parts each square is split into. Now suppose I want to add these two fractions together. So I'm going to try and add them together, but I run into a problem here because the shaded regions are different shapes and sizes. They're not exactly the same kind of, they're not split into equal-sized pieces that I can add together. So what we're going to do is I'm going to go back to the unit squares, and I'm going to go ahead and split the top one horizontally as I'm doing right now, so that the unit square is split into 6 equal-sized pieces. And then the bottom unit square I'm going to split vertically so that it has 6 equal-sized pieces also. And now we can see that the shaded regions in each unit square are all equally sized. And in fact, the top unit square now has 3 shaded pieces out of 6 total equal-sized pieces that the unit square is split into. And the bottom unit square is split into 2 equal-sized pieces out of a total of 6 equal-sized pieces. And we can see that now we can count up the total number of shaded pieces that we have, which is 5, out of 6 equal-sized pieces that each unit square is split into. And so we see graphically, using the pictures, that the total amount of shaded region is 5, 6. Now, that's looking at it pictorially. Numerically, really what we just did was I took the fraction 1/2, I multiplied the numerator and the denominator by 3. That's the same thing as saying I tripled the number of shaded pieces, and I tripled the total number of pieces that the unit square was split into, and I created an equivalent fraction. 1 times 3 is 3, 2 times 3 is 6. And for the fraction 1/3, I did something similar to that. I multiplied the numerator by 2, and I multiplied the denominator by 2 to create an equivalent fraction of 2/6. So numerically, all we're doing to add the fractions together is multiplying the numerator and denominator of each fraction by a value, namely the denominator of the other fraction, in order to create a denominator that is the same for both fractions, which is of course what allows me to then add the two fractions together. It turns out that this process, this numerical process, works for adding any two fractions together. And I'm going to go through a few more examples in part 2, where I focus only on looking at how we can add two fractions numerically by creating equivalent fractions in the fashion that I just did. We won't look at the pictures anymore as a motivating way to do that.